This is problem 8-105. Make a sketch of a graph p of x so that p of x equals 0 would have the indicated number and type of solutions. So we're talking about real and complex things here. So we're going to make graphs for all these for A. All right, so it wants us to have these solutions, which these basically mean roots or x-intercepts. So that's going to happen along this x-axis. We want 5 real, meaning it crosses 5 times. Scoot that up there. So I'm just going to go through 1, 2, 3, 4, 5, making sure it doesn't come back through and touch a sixth or seventh time. So that's our graph. That'll work for that. As long as yours crosses 5 times through this x-axis, that's good. Part B, 3 real and 3 complex. So let's draw our axes again. Oops. So remember, complex roots are imaginary. They mean the same thing. And let me just write that, equals imaginary. And that means that it's not going to cross the x-axis. And remember, they come in pairs. Okay, so there's always going to be 2 of them or 4 of them, never 3. That's not a pair, right? So we want to have 3 real, so that means it crosses the axis 3 times. So 1, 2, 3, and then our complex is actually this little dip down right here. Okay, so this is the location of the 2 complex roots. Even though it's in one location, the roots are in pairs, so we count it as 2 complex roots. Okay, for part C, we have just 4 complex roots. So actually these aren't going to touch the x-axis at all. So I'm going to have it start up here, and remember, it's the dip part is where the roots are. So right here in this dip, and right here at this dip, that's where the 2 complex, this is 2 complex and this is 2 complex. So that's a total of 4 complex. And then D, we want it to have 4 complex and 2 real. I'm going to start with the 2 real. Well, no, let's not, just for fun. So let's start with the 4 complex, which is basically the same thing that we had over here. So I'm just going to make it a little smaller. And then 1, 2. Okay. So right here is the 2 complex, because they're a pair. This is the other 2, so that's a total of 4. And then these 2 are the 2 real that are separate from each other. Okay? And the last part of the question, part E, says, for parts A through D, what is the lowest degree each function could have? So let me just bring up another random example here. So at one point, I'm pretty sure, you should have looked at this graph, and you were told that it was x to the 4th. And you're like, what? That doesn't look like a w, because that's normally what those look like. But, because normally you would think this is x squared, right? It's a parabola. But it could have been x to the 4th, and it looked like this until you zoomed in. And then you saw it was a teeny tiny w right here. So basically what this question is asking, what does it look like it should be to you? Not the biggest exponent, because this could be a 4, but what is the smallest exponent that it looks like it should be? Or what is the smallest number of roots that it should have, which is the degree. So basically you're just counting up the number of roots it has, real or complex. So that we have 1, 2, 3, 4, 5. So this one has a degree of 5. B has 1, 2, 3, 4, 5. So also a degree of 5. So they're different looking, but they have the same degree or the same highest exponent. Part C, we have 1, 2, 3, 4. Remember, those come in pairs, those complex. Get rid of this now. And part D has 1, 2, 3, 4, and then 5, 6. Okay? So it wants the smallest thing possible. Just like I showed you, that parabola could have really been an x to the 4th, but we wanted to assume the lowest possible degree or exponent that they could be. Okay?